This video is about showing how the ball earth shills that come to my channel defend their spinning water-covered sphere by describing a cylinder. Okay, so what I've said is, in order to see scenes like this, when the wind's not blowing, with perfectly still water, like glass, like a mirror. And remember, the Earth is still rotating, right? Hundreds of mile per hour water would have to turn. In the northern hemisphere, that would be turning to the left, right? Because remember, the ground is kind of rotating out from under the water. So for the water to turn, that would defy Newton's law of inertia, which is also his first law of motion. An object in motion will tend to stay in motion at a constant speed and in a straight line, unless there's some kind of force to change that. Now some would say, oh, gravity is that force that would change that p-brane. No, it wouldn't. Gravity actually aids in things going straight. Let me explain. As you throw something across the room, throw a pen across the room, piece of paper, you'll see it goes in a straight line. If you draw a straight line between any 2 points on a sphere, that's the beginnings of a great circle. A great circle is the biggest circle you can draw on a ball, and it bisects the ball. And a great circle drawn on a sphere shares the same center. The center of mass of the sphere would be shared, that center would be shared by the great circle. So that's how Newton came up with his things going in a straight line. It's consistent with his gravity being located at the center of the Earth, which we know is just co-opting our still, flat Earth, right? So essentially, as you throw that object across the room, it's like an orbit. Right? All orbits go straight. This is why they have their geostationary satellites above the equator, because the equator is not turning left or right. It goes straight, so they can get in sync with the rotation. Of course, it's all fake. They're not doing any such thing. But you can't have a geostationary satellite over a latitude and stay in sync with the latitude. It's not possible, because it will want to orbit the center of mass, and all latitude lines are a turn. Okay, everything would move at a right angle to the axis of rotation. And on a sphere, that takes everything to the equator. That would be dirt, rock, water, clouds, air particles. Everything would want to go to the equator. And as per Newton's law, everything moves in a straight line. On a cylinder, it would work with gravity evenly distributed throughout the pole, because there'd be no conflict with Newton's first law of motion, where things want to stay in a straight line, right? Because water would have to stay in a straight line on a rotating cylinder. To stay in its latitude lane, it requires a straight motion. So it works perfectly. And that's the only way you could see scenes like this, is on a cylinder where water would stay in a straight line. On a sphere, though, straight moving water is death and goes to the equator. Because to stay at latitude on a sphere and to see scenes like this, the water has to turn and stay perfectly in sync. And remember, the ground is rotating left. It's rotating out from under the free-flowing water, the hundreds of mile per hour moving water that's moving in a straight line. Okay, so this picture right here debunks the rotating Earth. Okay, so Charlie Goy said to me in a comment, "Hi there, brother p-brane. You present such an effective proof that totally invalidates a spinning globe Earth. Have you come across any serious rebuttal?" Yeah, right. I don't know if I'd call them serious. They've definitely been confused. There's some confused ballers out there. Perhaps that would be an idea for a video. Well, thank you, Charlie Goy, and here's a video on just that. I picked a couple guys. They could be the same guy for all we know. They could be Neil deGrasse Tyson for all we know, right? JSS Tiger and Wolfgang Lawn. Okay, they describe a cylinder. And I'll prove that to you in their comments. Okay, here's JSS Tiger. He's quoting me. So I said, water's got to move to the equator. No, it doesn't. The water tends to go outward, parallel to the lines of latitude, perpendicular to the axis of rotation, p-brane. Here's another JSS Tiger. Water would have to turn. That's what I said. Insert whack twack. That was a good one, p-brane. So he's laughing at me saying that latitude lines are a turn. They don't even understand how their sphere works, or with the latitude lines. He just sees this 2D picture and thinks, there you go, the latitude lines are at a right angle to the axis. No, they're not. Not the surface of the sphere. On a 2D drawing, sure, it looks like that, but you don't traverse the outside of it. If you did, that would be traversing a cylinder. We're talking sphere. So you can see the surface of the cylinder is parallel to the pole, but not the surface of the sphere, right? Only at the equator is the surface of the sphere parallel to the pole. As far as your question, why wasn't your tape measure parallel to the axis of rotation? Because my tape measure is on a sphere, Dumbo. The surface of the sphere is not parallel to the pole, except for the equator. On your cylinder, yes, that's what you're expecting in your mind. The cylinder, the surface, is always parallel to the pole. Here with my rubber ball, you can see clearly I put this straight line against the ball right over the latitude lines. Now you can see a JSS, Dumbo. Latitude lines are a turn. All the water would be pushed straight, perpendicular to the axis of rotation, just like you said. And on a sphere, it goes in a great circle, and a great circle takes it to the equator. Okay, and now for the other winner, I promised, Wolfgang Lahn. He says, on a ball without any attractive force of its own. Okay, he's not talking about the Earth, I guess, because he said, on a ball without any attractive force of its own. He must be talking about this. The guy throws the red ball up, and the water all spins off and spins to the equator and spins off. Okay. So he says, on a ball without any attractive force of its own, rotation causes centrifugal force, right? Which is always pushing things away from the axis and at a right angle. Hence, water remains at the same latitude. Oh wait, did he just switch to the Earth? To the ball Earth? There is no force to push it to the equator. Okay, I think the force we should be looking for is the force that's going to cause water to turn around the pole. That's the force, because going to the equator, as I just showed already, it's a straight line, right? As I show on this ball, a tangent or a right angle to the axis of rotation on a sphere does not stay at latitude. It clearly shows here latitude line is a turn. From the side view, it may look like a straight line. It's kind of like looking at a racetrack from the, eye level. It could be a circular or an oval track and it'll look like a straight line, but clearly it's not a straight line because the surface is what matters. The surface of the sphere, when you put the straight line on it, the straight line goes down to the equator. Okay, so that's the force we should be looking for. He says there's no force to push it to the equator. Well, Newton's law of inertia. Everything wants to go in a straight line unless there's some outside force to change that. So Wolfgang Lahn and JSS Tiger, what is that force that would cause water to rotate around the pole? Around the axis of rotation, the pole. Do enlighten us. Okay. All right, everybody. I'll wait for you to hear a response from some ball earthers. We want to know what force is there to make the water rotate around the pole. All right. Talk to you guys soon. Bye.